strong bond. Like the transition metal, like if you are going transition metal having more unpaired electron, like iron, if you go cobalt, nickel, and titanium, chromium, they are having more unpaired electron, so they are strong metallic bonding. If you talk about the alkali metal, only one electron is there, one electron. So weak bond is there. Weak bond means, metallic bond means low melting point. MP is low. Why the low melting point? Because the bond itself is very weak. Getting? Only one electron is there, so obviously the bond will be, what will be? Weak bond, low melting point. Down the groove, if you are going, size increases, so attraction decreases. Attraction decreases means bond become weak. Yeah, no? Bond become weak. So bond becoming weak means melting point. What will be their melting point?
Increase. No, decrease.
Decreases. That is what the point was there. Can you understand?
Yes, clear.
Here, you read this slide. Hydration enthalpy here, this one we studied the hydration enthalpy. Here they wrote the hydration enthalpy in this case also. Here, now it is not allowing me to write anything on this one page. Here, we are supposed to study which point we are studying. Melting point. See the melting point here also. They are soft and light metal because of the large size. These elements have low density. They did not mention too much. The melting point and boiling point of alkali metals are low, indicating weak metallic bonding due to presence of only one single valence electron in them. The alkali metals and their getting this point. Melting point. Yes, yeah, no.
So melting point is clear.
So first is melting point. Here you see the order of melting point is there. 454, 371, 336, 312, 302. So it is decreasing. Boiling point also decreasing. Boiling point. The same region. 1615, 1156, 10 decreasing. Yes or no?
Yes.
Next point. Yeah. Which of the following alkali metals is expected to melt if the room temperature rises 30 degrees? So lowest melting point which is there, cesium, down the group.
Yes, cesium.
Okay. Flame test. What is the flame test? If you are, suppose flame test is there in the lab also, if they explained in your lab, okay.
Sir, in our lab presently, sir, that one is going on. Sir, that salt one. Sir, today, sir, they gave us one salt and sir, we rubbed it on our hand and some smell was coming out of that after washing.
You need to find the cation and anion, these all things. You discuss with your friend in the SGS what they have done, that one also. Did you talk anybody or not?
No, sir.
Not a single friend you are having, SGS?
Sir, I am having a lot of friends, sir, but when I came there, then it was vacation going on, sir, I met nobody.
But you can have the phone or WhatsApp sometime. So they
I will call.
You will have someone. So what you are taking, if you are taking pinch of metal in the flame, so it impart the different color. Okay. So what are the color are there? See, read the concept. The alkali metals and their salts impart the characteristic color to on flame. Heat from the flame excite the outermost electron to a higher energy level, and excited electron come back to the ground state by the emission of radiation in visible region. And any radiation in visible region are colorful. Any radiation in visible region is colorful. So what they are saying, suppose Electrons are there, two different levels are there. Okay. According to Bohr's atomic model, if electron is here, it absorbs the energy from any source, it absorbs the energy. So what will happen? It will jump here. Electron jump here. But this cannot be in the higher state. So it will fall. When it will form, that is, it lost the energy, loss of energy. If it is lost the energy, then it form. And this loss of energy is what will be? The colorful, na? Color. Visible region, it will be color because it is the radiation. It will come be in the Vibgyor, Vibgyor, in this region. So it will be color. So that is what they are saying. What is the color of lithium? Crimson red. This is important. Sodium is yellow. Potassium is violet. Rubidium is red violet. Cesium is blue. These points are blue. These are important. They ask in the exam.
Sir, I'm writing right.
It is there in the NCERT. You are writing, that is very great, but most of the, you try to learn the concept. Most of the notes are there in the NCERT.
Okay. So then I'm not writing.
Everything don't write. Little bit you what you find the important, na, that one you write. Because if you keep on writing, more energy will consume. Because these notes I can share you. There is no problem. Photoelectric effect. This is there. Photoelectric effect. Photoelectric effect in the atomic structure is also there. And when we were studying the photoelectric effect, I told you that is which metal we use? Cesium metal we use. Why cesium metal we use? Because its ionization energy is lowest. So what will happen? Electron easily get excited in the case of cesium metal. Getting?
Yes.
So that is why in the photoelectric cell it is used. Here you see. The ejection of electron from the surface of metal is known as the photoelectric effect. Property makes them cesium and potassium useful to electrodes in photoelectric cell. They are making electrodes. Why? See. This is the plate. Right. When the radiation falls, sunlight fall on this one photoelectric cell. Right. This light are falling. So what will happen? This electron will eject. This electron are ejecting. And this electron is going. This electron is going. Where it is going? Reaching on this one receiver. So this is, if it is made up of the low ionization energy metal, so electron will easily eject now. Yes or no? Its ionization energy is very less, cesium metal. So even if the dim light is there, dim sunlight also, the electron will eject. And the circuit will complete and battery will get charged. No.
Yes.
Okay, next one. Density. Density. So here, density of the alkali metal are low and moving down the group increases with the exception that potassium is less density than sodium. Potassium has vacant d orbital. So vacant is more and density is less. So there is the exception is there, sodium and potassium. Otherwise, moving down the group, density increases because the mass is increasing, so the density increases. But if you see potassium configuration is there 1s2, 2s2, 2p6, 3s1, 3p0, 3d0. No,
You are zero.
wait. 4s1, 4s1, 19. But here is in the meanwhile, it will come 3d also come na 3d0. So the size, it increases the size. So density is equal to what? Mass by volume. So volume will increase, so density will be less in case of the
Then
potassium.
why we are considering a 001?
What?
Sir, why we are considering the zero cells?
Where
That I'm asking.
where I am considering zero? Where? See?
Sir, you just wrote it.
No. I configuration. I wrote the sodium. That is why 1s2, 2s2, 2p6. See, 3s2, 3p6, 3p0, 4s1. This is configuration now. In d orbital, there is no.
Question.
So d orbital is what is? This is the vacant now. Firstly, electron field 4s orbital, then 3d. Above rule. Not getting.
Not getting very properly.
Okay. So above rule say how the filling of electron takes place. Above rule, according to above rule. Which one filled first?
Sir, that we are writing one to page to all the answer and we are doing
Okay,
that.
1s, 2s, 2p, 3s, 3p, then 4s, then 3d. Yes, yeah, no. Then 4p.
Yes, you're writing like this.
This is
Two
above.
is 2p.
But after arranging, this will come. D come first. Hmm.
Yes.
D come first. See. It is not
Sir,
Sanoji.
first it is coming 4s, but then it is coming 3.
No, you are wrong. 4s and then 3d, no? This one, 4s and 3d. But how you write? Three, same principal quantum number, na? 3, 3, 3. Same principal quantum number. Principal quantum same means what? In the same orbit, this orbital belongs.
Sir, my question is, sir, just I am asking one thing. Sir, why we need to write this one? Sir, this 3D0 means, sir, it does not exist.
It exists here. Third period, na d orbital come. Third period, when the third period start, d orbital come. D orbital. It is not, the only thing is there, it is not having the, it is not having the, what to say, electron. Suppose you see the nitrogen and you see the phosphorus, right? Nitrogen do not show variable valency, but phosphorus is how many are there? 5. Why it is having 5 and it is having 3? Because it is having d orbital, na, it can extend the electron. So oxygen, you see, oxygen valency is 2, but sulfur valency is how much there? 2, 4, 6. Why? Because it is having the d orbital, 3d orbital. So d orbital is there, it can gain the electron, it can expand the electron. Don't know. Hello.
I think I understood.
Not able to understand, your sound is also not coming, na, network issue your side is there.
Sir, now my sound is coming.
Yeah, coming. Did you understand this?
Yes.
Yes, yeah, no. Write down yes
Yes, sir.
or no.
Sorry.
Okay, good. Good. See, okay, Sanoji. Now see the next one. So that portion I explained that one. Density I explained. Why potassium is less density than sodium. You need to memorize that one. Which is wrong regarding the density of the alkali metal? Tell me. See, the potassium is
D only, sir, because sodium will be more than potassium will be more than sodium.
no, potassium will be less than sodium.
Ah,
Because it
sir,
is
opposite. So
yeah.
potassium is less than.
Okay, thank you. See here, the density order is there. Element and density. Potassium density is 0.86. Sodium density is 0.97. So K has low density. Reaction with air. Reactivity with air reactivity with air down the group increases from the lithium to cesium. Because the reactivity also increases now. Reactivity of transition metal increasing because the ionization energy decreasing. So reactivity also increases. So cesium react more fastly compared to lithium. So here the lithium is forming monoxide, sodium is forming peroxide. This is the peroxide, and this is the superoxide. See, here the point are there. Lithium monoxide, sodium, potassium, sodium, monoxide and peroxide, both. Potassium, rubidium, cesium. This is forming superoxide. Here oxidation number -2. Here is -2. Here is -1. Here is -1/2. So, lithium. Oxygen. No, oxygen oxidation number is -2. See, Li2O. So lithium is 2x. Oxygen will be -2 is
Yes.
equal to 0. So 2x is equal to 2. So x is equal to +1. So
Plus one.
oxygen, in case of monoxide, oxygen oxidation number is -2. But in case of peroxide, oxygen oxidation number is -1.
Minus one.
In superoxide, oxygen oxidation number is -1/2. Suppose RbO2. This is there. So I consider X plus 2 multiply by what will come? 1/2 minus 1/2 equal to 0. So here see X, if you solve this one, -1 equal to 0. So X will come +1.
Okay.
Oxidation state of oxygen in monoxide -2, peroxide -1, superoxide -1/2. So this is there. See, lithium form monoxide, sodium form peroxide, while other metal form superoxide. Stability and basic strength decreases down the group. See, down the group you are going, increasing the order of basic strength. Solubility, and basic strength decreases down the group.
Solubility and basic decreases down the way.
No, both it cannot not be decreased. No, this is not decreasing. The stability of is there, superoxide increases. It is not decreases. It will be increases. Why the increasing? See here, the bond will be weak now. Bond will be weak. So it will give easily ions. It will give easily OH ion. So increasing order of basic strength will increase. Here you see. Somewhere the slides are. Give me a little bit time. Will clarify your doubt here. Reactivity with alternate here. They did not mention on that. Here. See what is the point is there on combustion here peroxide. Increasing stability of the peroxide superoxide as the size of metal increases due to stabilize large data. Here also this. Let me explain to you better this video. What is there? The point is C. LiOH is there. Okay. NaOH,
Yes, sir.
KOH, RbOH, CSOH. Okay. What is happening? Size increases. Okay. So bond decreases. Yes or no? Bond strength decreases. Yes or no?
Yes, sir.
Bond strength, because attraction will decrease. So bond strength decreases. So easily gives H plus ion. Easily gives OH minus ion. So basic strength increases. So basic strength increases. So on moving down the group, basic strength will increase. So now anything is clear.
Yes, sir. Yes.
Yeah, so this is there. So here you see this one is these are the points are there. The stability of peroxide and superoxide. So this is the increases, not decreases. These all are the increases. Here you see the next one question are there. Here this is the question. Among the following metal, which metal forms the superoxide of the type MO2? Potassium, rubidium, cesium. So all these form the superoxide. Only lithium form monoxide, sodium form mono and para, matlab peroxide and other form superoxide. Which alkali metal no, which alkali metal, what is the point are there? Nitrate on heating gives the NO2 gas, lithium. This one, this is the important one. The reaction with nitrogen we did not study. Here you see. Here, see, we read this one. Air. If you are treating with the air, Samay, what are the compound you are getting? This is firstly reacting with the oxygen. But here you point here the microsur. Is it visible? Microsur is visible to you.
Sir, I did not follow, sir. What you told?
Microsur is visible here. Li3N. Can you see?
So, no, sir. Sir, what you are writing, I cannot see.
It is not shared or what? The screen.
No.
Is LCRT book is visible to you?
Yes, sir.
So what this line can you read here? From here, can you read? Because this is not allowing me to write. Here you see all these oxides of the oxidation state of the alkali metal is +1. Lithium show exceptional behavior in reacting directly with nitrogen to form nitrite, Li3N, as because their high reactivity towards the air, water, alkali metal are normally kept in kerosene. So lithium is the exception. Lithium is the exception. So that is what the point are there here. Okay, I hope it may be clear to you. So this is lithium is exception. So here the question is there. What the question is there, if you can see. This point. Group 1 compound metals, nitrites, decompose to give metal nitrate and oxygen. Which one? Only lithium is forming now, Li3N. This is forming. So there is all the group 1 metals, nitrates, decompose to metal. So here is, this is the, what the compound is there? MnO2 and oxygen it is giving. This question asked in the exam, that is why I am discussing. What the question is here, since the lithium show diagonal relationship with magnesium, it show the different behavior. Lithium LiNO3 is there, what the compound it is giving? 4NO2. This will give the NO2. So this question asked in the exam, what the question is there? Which alkali metal nitrate on heating give NO2? So the answer is lithium. Only keep in mind, this is the lithium gives the NO2 because it is the exceptional one. Lithium nitrate decompose like group 2 element to give NO2. This point you need to keep in mind. The lithium only gives the NO2. Remaining, if you see what is the time. Reactivity with oxygen, this all things we will study in the tomorrow. I will check back this one. I will share one PDF to you. Okay, this PDF. You go back and see if anything, if you are getting time somewhere, right? This point. Okay. Here, why I am giving this one? Because some problems are there. That problem is conceptual problem are there. That problem you will be able to solve. Here you see, the point are there. Alkali metals are good reducing agent because they give the electron, na alkali metal. They give the electron, valence electron. What they can lose the valence electron readily on account low ionization enthalpy value. So it's what will be there? They will act as a reducing agent. Which alkali metal ion has maximum polarizing power? Lithium metal polarizing power. Lithium metal is high polarizing power because it is smallest size. Okay. Which rule you have to go? Fajan rule. Fajan rule. I explained to this to you. So now, see, these questions are there. If you in the free time, you can read this question. Here, see, why do KRBCS form superoxide in preference to oxide, peroxide being the heated excess supply? So what they are saying, KRBCS, large cation in size, and superoxide O2
Superoxide is
minus.
larger in comparison to oxide.
So this is why, that is why it is. Why is KO2 paramagnetic? They are saying KO2 is paramagnetic. So when you are writing the, it will give what? KO2, if you are ionizing KO2, let me explain you. This question KO2, upon adding KO2. So it will give K plus O2 minus. O2 minus. O2, if you are giving two unpaired electron in anti-bonding. So O2 minus one unpaired electron. So one unpaired electron is there in anti-bonding, so that is paramagnetic. Here, see, super paramagnetic because one unpaired electron is there. Getting this one, molecular orbital theory.
Yes, sir.
Among the alkali metal, which element has highest melting point? Which alkali metal have highest melting point? Lithium.
Lithium.
Highest size of hydration enthalpy? Lithium. Strongest reducing? Lithium. Least electropositive, least electronegative, cesium.
Electronegative.
Cesium. Down the group, electronegativity decreases. So cesium. Slowly you will be covering. Okay, but it will take time. Okay, so did you get any information from today's class?
Yes, sir. Sir, I got that one, sir. The photoelectric effect, density, stability, that one, sir. Flame testing, melting point, hydration enthalpy, reactivity, and occurrence of this one, sir. Alkali metals occurrence, electronic configurations.
Tomorrow we'll connect you again because I need to go for the dinner and then again tomorrow again classes are there. But night time surely I will take. Tomorrow you can take more time because Saturday you can take more time. Saturday I don't have the tuition. Most of the tuition is off on Saturday because exam 12th pre-board is going here now. 12th pre-board from
Okay,
tomorrow.
sir.
So maybe tuition will not be there. So Saturday I can give you more time as much as you want evening hours. Okay.
Okay, sir.
Okay. Bye. Take care.
Okay. Good night.